Okay, in this section we are going to talk about need for coordinate geometry. This is going to be one of the important area in the mathematics which you will learn more in your higher classes. Today we are going to talk about why was the need of coordinate geometry, where it originated from, and we'll try to understand this through some examples. So we'll first start to understand how do we locate a dot on a paper if I don't have coordinate geometry. And then how do we locate them with the help of coordinate geometry? And then we'll also talk about seating plan example. And then we'll go and look into what has caused a coordinate geometry to come into existence. So assume you have a paper and you put a dot on that paper, what you can see here in the screen. Now if we ask you to locate this dot, how will you do this? Some of you can answer the dot is in the upper half of the paper, and which is right, because if you divide this paper into two parts, this dot is in the upper half. But again, this does not tell me that what area on the upper half, because upper half is a big area and it can be anywhere. So even though it looks right answer, but it's not an exact answer. Some of you can answer that it is near to the left edge of the paper. Now you see this paper has right edge and left edge, and if you look between these two edges, you can easily see that this is closer, but the closer definition is again a relative position. It can be here, it can be here, it can be anywhere close to this. So even though this seems to be a little bit good answer, but it's not an exact answer. Some of you can also answer that it is very near to left hand upper corner. Now you know a plain paper will have 4 corners, right? So 1, 2, 3, 4. Which corner is left hand upper corner? This one is left hand upper corner. And it seems this dot is closer to left hand upper corner. Again, if you move this dot from here to here, that becomes more closer. If you move a little further, then it becomes more closer. So there is still not a unique way or exactly to define the position of the dot. These are all answers, but they're not giving you exact position of the dot. And hence, do any of these statements fix the position of the dot precisely? The answer is no. Now we'll try to identify how do we really take help of coordinate geometry to really define precisely where the dot is placed in the paper. Now you can see in this example, we have tried to identify dot using 2 perpendicular lines, right? And then we can say the dot is 5 centimeters away from the left edge of the paper. This is the left edge, and if I draw a perpendicular line on it, and if I measure this, and if this is 5 centimeters, then this dot is 5 centimeters away from the paper. But then you can see any dot on this can be 5 centimeters away. So it is still not fixed position. So I need another variation. And that variation is, it says 9 centimeters above the bottom line. So this is my bottom line. And if I go 9 centimeters above it, then the perpendicular line from 5 and perpendicular line from 9, they intersect at a position, and that position gives me an exact position of the dot, which is 5 centimeters from left edge and 9 centimeters from the bottom edge. Note that position of any object lying in a plane can be represented with the help of 2 perpendicular lines. 5 centimeter and 9 centimeters. In case of dot, we require distance of the dot from the bottom line as well as from the left edge of the paper. You cannot just define position of a point or dot on a paper just by providing one parameter. You need to provide two parameters in order to really fix that position. Now let's take an example of seating plan example. Let's assume you have to draw a plan of seating in your classroom, pushing all the desks together. So what you are doing, you are just squeezing all the desks together. There is no space between them. Every desk is one after the other. Represent each desk by a square. Now on your paper, if you are assuming, you just draw a square for each bench or each desk which is there in the class, assuming one student sit on one desk. So then you have combined all the desks together. Every desk is in a square and every square has only one student in it. Now with all that combination, if I ask you to describe me position of an student where the column in which he or she sits or the row in which he and she sits, you can see your paper will turn out something like this, where you can define columns and rows, and every desk of the class can be represented as a square. And now, if I ask you to tell me if you are sitting on a desk lying on the 5th column and 3rd row, what will be your position? How do you locate this? First, write the column number and then write the row number. So assuming you have to first tell me what is your column number and what is your row number, and if that is a case, your answer will be 5, 3. Now how do you represent that on the plain paper which you have converted into multiple squares, and every square represents a desk on which one student can sit? If you have to represent it, look, you have to go 5th column. So I have column 1, 2, 3, 4, 5. This is my 5th column. And now I have to look for 3rd row. So I have row 1, 2, 3. This is my 3rd row. Now if you intersect 3rd row and 5th column, then you come to this position of the square. And that is exactly where you are located. And this can be represented as 5, 3. Now let me ask you, do you think 5, 3 is same as 3, 5? Well, the answer is no. Why? 5, 3 is shown in the above figure already, which we have seen. 5 represents column, so 5th column and 3rd row. However, 3, 5 is 3rd column and 5th row, which is this place, and hence these two places are not same. So 5, 3 is not same as 3, 5. Now let's take another example. If you are sitting on a desk which is laying in the 8th column and 4th row, what will be your position? Assuming the way I ask you to locate is first write the column number and then write the row number. It's going to be 4, 8 or 8, 4. The answer is 8, 4 because you put column first and then row. And if you have to locate this, you can see 8th column and 4th row, and this is your position. Now let's try to understand, after looking into all of this, what has really led to the origin of coordinate geometry. The idea to represent a point on a plane. So the idea to represent a point on a plane, which is your white paper, or any kind of plane which you can consider, has raised an important concept in mathematics called coordinate geometry. This study was initially developed by French philosopher and mathematician René Descartes. In honor of him, the system used to describe the position of a point in a plane is also known as Cartesian system, which we will discuss further in the next session. Thanks for watching. You can visit us on www.classisfun.com.